All right, physics gurus. So one of the famous physics problems that we look at is an elevator, and so how an elevator works. And usually we use Newton's second law to describe this. So we're going to go through one such examples here. So imagine a person gets on the elevator and their mass is 78 kgs or kilograms. So you want to know what forces are acting on her. So all of the forces together. Remember, that's called the sum of the net forces. So you know that gravity is pulling you down and gives you your weight. So that has to be acting on you. But the elevator is also pushing back up on you. So your net force is 0 because you're not moving. So your acceleration must be 0. So your F weight has to be equal and opposite to the F elevator, of the elevator pushing it back up. So we want to find your F weight. So remember, weight is mass times acceleration due to gravity. So we have 78 kgs times negative 9.8 meters per second per second. And remember, the negative just means it's acting downward. So we get a weight of negative 764.4 newtons. Okay? So if that's the force acting down on you, the elevator has to be pushing back up on you to get a net force of 0. Okay. Now, a lot of times you can see a bathroom scale, like you can step on a bathroom scale and that would read your weight. And so that's what it would read if you were in an elevator and you had a Newton scale, of course, that it would be 764.4 newtons. Okay. Now, let's say that you push the button to go up, any button, and you see an acceleration right away of 0.62 meters per second per second. So we want to know, what is that net force that is causing you to go upward? And so we look at our formula that net force equals mass times acceleration. So that's just rearranging Newton's second law to solve for forces. So your mass hasn't changed, so that's still 78 kilograms. And that's going to be multiplied by 0.62 meters per second per second. Now, why is it positive? Because the direction is up, and up is positive in this case. So F net, to pull you upward, would have to be a net of 48.36 newtons. And again, the up is the positive. All right. Now, if we were to continue this and actually put a scale on there, to try to figure out what, I guess film scenes having a movie, try to figure out what the weight would be in newtons, your weight would change. So if we're accelerating upward at that same 0.62 meters per second, what would happen? Okay. And so remember that the sum of net forces equals your weight plus the elevator pushing back up on you. Now we know that the F net from the last step was 48.36 newtons acting upward. So now we have to put that back into our formula and say, okay, so 48.36 newtons is my net force equals my weight, which is negative 764.4 newtons acting downward, plus the elevator, okay? And so when I solve for that, you get a weight of 812.76 newtons. Now that's pushing back up on you. So notice my weight went up. So when acceleration goes upward, your force, net force is acting upward, you feel like you weigh more, okay? Kind of feels like it's almost pushing you down. That's looking at inertia. You're at rest and then the elevator moves. So now, imagine if you push that button and you go down. Now, sometimes the elevator gives you a different acceleration going down, but just for our purposes, let's say it's the same acceleration. So 0.62 meters per second per second. But again, the down means that I have to put a negative in front of it. So I go back to my forces equation, but now my F net has to be negative 48.36. All right. So acceleration is acting downward, so the force would also act downward. So now if I solve for that and put negative 48.36 newtons equals negative 764.4 newtons plus whatever the elevator is pushing back up on me, you get a net force of 716.04 newtons. So when I'm going down, you feel like you're weighing less in the elevator. okay? All right, so now we know, hopefully I have a little typo there, going down an elevator. Now we know how to solve for acceleration in an elevator, or how to solve for the force in an elevator. And thank you for watching. Physics gurus. So a typical physics problem deals with an elevator. And so you can use an elevator to really explain what happens to you as you go up and you go down. And there's my kids. Hi, physics gurus. So today we're going to look at an acceleration problem using an elevator. So elevators are great examples of physics, trying to figure out what happens to the force when you're going up in an elevator and when you're going down in an elevator. So for this problem, we're going to imagine a person that weighs or has a mass of, 78 kilograms, and gets on an elevator. So what forces are acting on her? I don't know. Hey, physics gurus. So one of the classic physics problems that we've been looking at has to deal with an elevator. So when you get in an elevator, you have forces that push you up and forces that help you go back down to different floors. So we'll look at that today. So in this problem, we're going to imagine a person that has a mass of 78 kilograms or 78 kgs, and they get on an elevator. So what forces are acting on this person? Now remember, all of the forces together is called the net force. So the sum of the net forces would be her weight, her gravity pushing her down. That would give her a force of her weight. Plus the elevator has to be pushing her back up. Okay, so in my system, I'm just looking at me on the scale here. So if we know that the net force is 0, and you know it's 0 because she's not moving, he has no acceleration, no change in velocity, so that's 0. So your F weight pushing you down has to equal the weight or the elevator force pushing you back up in order for you to get a net force of 0. So let's solve for F weight. Or weight, it would be your mass times acceleration due to gravity. So we have 78 kgs times negative 9.8 meters per second. And the negative just means that I'm acting downward. So when you multiply those two out, you get negative 764.4 newtons. So that's your force acting down. And again, since you have to have an equal force acting back up on you to get a net force of 0, that means the elevator is pushing back up at 764.4 newtons. So if I were to put a bathroom scale underneath me, that is the force that I would see in newtons, of course. So we're in our elevator and you push a button to go up and you have this handy dandy accelerometer and it finds an acceleration of 0.62 meters per second. All right. So what would the net force be that causes that acceleration? All right. So now net force, if we rearrange Newton's second law, F equals ma, FMA. So F net equals mass times acceleration. Now your mass hasn't changed, so it's still 78 kilograms. And we have to take that times 0.62 meters per second. So notice that that is a positive. So the positive would be in the upward direction here. So my F net would be a positive 48.36 newtons. And again, the positive means it's going up. So net force is going up, acceleration is going in the same direction. Okay? But the cool thing to do in physics is try to predict what would happen to your weight. What would you feel like? All right? And so on this one, if you still have that same problem, we want to see what her weight would be. Okay? So you again go back to the F net equals your weight pushing down plus the elevator pushing back up on you. And you already know from the last problem that the F net for this acceleration is 48.36 newtons acting upward. Okay, so now plug that back in. So I have 48.36 newtons has to equal negative 764.4 newtons plus whatever force the elevator is. Okay, so remember, if you have a negative, you're going to have to add that to get rid of it. All right, so I have 48.36 plus 764.4 newtons. And that would give you a force of 812.76 newtons, okay? So this scale would be pushing back up. It makes you feel like you weigh more when you're going up in an elevator. Okay? So upwards means that you have an increase in your weight. Okay? Now, on the next one, let's look at the same acceleration. Keep the math simple. And I go down. And now I still have this same acceleration. To show that I go down, I would have to have a negative acceleration. All right? So I have still a negative 48.36 would be my negative force pushing me back down. And again, this is similar to the last problem. Only now, when I move my weight to my other side, you end up subtracting that F net. So you get less weight. So you feel like you weigh 716.04 newtons, okay? So that bathroom scale would actually go down that much. And most of you saw that in the lab that we did too, all right? So remember, going up in an elevator, your net force is up, and it causes you to feel like you have gained weight. You have an increase in weight, okay? When you go down in an elevator, the net force is down, the acceleration is down. You feel like you have less weight. All right, thanks for watching.